Hi there. We're going to be taking a look at some new technology we have to detect contamination in natural gas systems, specifically at custody transfer points today. My name's Paul Stockwell. I'm the Managing Director with Process Vision, and you can contact me at paul.stockwell@processvision.com. So if we take a look at the gas journey from the gas wells through gas processing, through the custody transfer point here, onto the gas network, and then to point of use or power stations, petrochem plants or LNG plants. We have applications here in the gas processing plant here, but today we're going to be looking at this point here, the custody transfer point. So this is a point where the gas is effectively changing hands, it's custody transfer. And at this point there is a contract between the buyer and the supplier that specifies gas quality. That might be in one particular page or throughout the contract really, but normally it specifies the moisture content, H2S content, BTU, maybe CO2 content of the gas as well, basically all about the gas quality. But in addition to that, there's normally some form of words along the lines we see here that specifies that there should be no free liquids or any other substance that might interfere with merchantability or cause injury or interference with operation. So it varies throughout the world. This is an interstate pipeline contract from the USA, but it's just an example there. So this is because of safety. It's mainly safety driven because the networks really don't want to see any lumps in the gas that enters their pipework. And the reason for that is there are a number of incidents every year where things happen due to contamination. This is a pipeline rupture happened a few years ago. These are trees here in the flames to give you an idea of scale. And one of the separators failed at the gas entry point or in the network and allowed liquids to move forward into the network, and pooled at this low point here just beyond the bridge and gently corroded the point to the point of rupture. So with the liquids pooling here, they can accumulate up to a point where there's enough there to form a slug flow, and a slug flow will move quite rapidly through the pipeline. And when it comes across the gas separator, that every 100 miles or so, there's a gas compressor, sorry, every 100 miles or so, then this kind of thing can happen. They're not designed to accept a large amount of liquid. So to cope with that, gas networks have set up a series of things that they can do to counteract that or mitigate that. And some of them have added extra knockout parts, extra separators at their cost. Others pig sometimes up to 4 times a year. And this is the kind of thing that they pull out when they pig the line. Some of it is dry material and some of it is a slurry. We now, from our observations with our system, we understand a little bit better the process that's going on within the pipeline itself. So as contamination comes across, a series of liquids perhaps mixed with solids, the rapidly moving gas above it actually draws off the lighter end liquids preferentially, and you're left behind with an ever drying material on the pipe wall, and that's why we see dry material coming out on occasions. So when we look at the cost of pigging, it's costly for both the supplier of the gas and for the network operator as well. When we look at the cost just in terms of loss of revenue for the supplier, then we're looking at a pigging velocity of 11 miles per hour as opposed to a normal velocity of, say, 25 miles an hour. So that loss of flow equals loss of revenue. So if we look at a 36-inch line, then we've got basically $5.5 million that day just through loss of revenue that day. And these are October 2019. We're now October 2020. The prices have recovered to about the same sort of level. So why is this happening? Well, gas analyzers at the custody transfer point are quite simply that. They analyze the gas. They're not designed to look at liquids that might be entrained in the gas. So the takeoff point for a start is in the middle third to avoid anything that might be on the pipe wall. And then there is a series of filters and separators between here and the analyzer itself. So the contamination coming through the custody transfer point will have an effect on the flow metering. It's well documented that orifice plates, certainly on ultrasonic stuff, flow meters will overread if there are liquids there. The trick is to know if there are liquids there or not. And they can overread up to about 5%, depending on the amount of liquids. Now, we thought originally that that was it during that event, whether it be 3 hours or 3 days, but during that event, the flow meter would overread. We now know that because of this separation in the pipeline, there can be some permanent reminder of that contamination event, so that what we've seen is stable material on the pipe floor that effectively reduces the pipeline diameter, only marginally, it's just a few millimeters, but if that's happening in the flow skid, in the flow line itself, that will have an effect, a permanent effect on the flow metering. And Sarbanes-Oxley bill is kicking in now for due diligence on fiscal measurements. So it's important that we take account of what might be there. And so we've generated an Excel spreadsheet. You can download that free from our website. It simulates this situation here where you've got gas coming in that's split into multiple flows, and there's a flow meter on each of these legs here. And so if we take a look at the effect of just a few millimeters of contamination, we've been seeing sort of 2-3 millimeters of contamination at the bottom. And now, if that was an 8-inch line, that would be about 0.3%. If it's a 6-inch line, that goes up to about 0.5% error on the flow metering. And these flow meters are trying to keep the total uncertainty under 0.5%. If we look at the effect of that on cost, then 3 millimeters again, you're looking at $250,000, and then just over $400,000 if it's a 6-inch line. So if you download the calculator, you can just work your way through the 1 to 5 boxes here. The orange cells you can change, whether it's a number or whether it's a scale here. And put in the parameters that you have on your particular system and simulate the number of flow meters you've got and their size, and then just play around with the amount of contamination that might be there and see the effect in terms of dollars. So what we have is contamination in the pipeline, and we can see that in our system with a camera, and the camera sits over the pipeline itself. This is the camera can, and we're normally installed the other side of an isolation valve when we look down into the pipeline below to look at the pipe floor effectively. So normally it's we don't see any movement at all really, other than the gas moving through the line, and we use image processing to flick an alarm should we see contamination in the flow. So this, for the first time, can monitor the separator efficiently. Or efficiency is permanently installed downstream of a separator, so we can take a look and see under what circumstances separators are having problems. So gas processes can significantly improve their process, and gas networks can use it to improve their accountability. They can show the supplier live what they're actually sending them at any given time. So if we take a look at the system in more detail, then we've got the system in the field of the pipeline, and then there's in the safe area we've got an interface box and controller here, and we have a SIM card here, so remote access is possible for approved users on tablets and mobiles. And this is the LineVu here with secondary containment, and that gives us enough safety level to be attached to a pipeline network. And this is the user interface. So imagine you're standing on top of the pipeline looking down below. This is the sort of thing you might see. So thanks very much. You can contact me on paul.stockwell@processvision.com. Any questions, or just visit our website. Thanks very much.